let's try out this problem. Is this phase known or phase unknown? Well, because there aren't any deceased people in the family, and because the first generation has one offspring, and then that one offspring has many more kids, we can rate this as phase known. So if we look at the mom, she does not have the disorder. So we can write it like this. And the dad, he does have the disorder in the A marker. So we can set this up like this. And then their offspring does have the disorder. So they got one set, the capital D A from dad, and then they got their B marker from mom. So over here, we know this person is shaded in. So they got the disease gene with marker A from dad. And then the mom is homozygous, so she can only give a small d and a c. So no recombination took place. So we're going to rate this as non-recombinant because we got a set from dad and then a set from mom. And then also something to note, we don't want to score people from outside of the family. So now this person, they are BC. So they got this small d B from dad and then small d C from mom. So non-recombinant. We don't care about this person because they are from outside the family. Here we have a person shaded in. So they got a big D A from dad and then a little d C from mom. So non-recombinant. Here we have little db and small dc. So here and here, this is going to be non-recombinant. And this person has a B, but they are shaded in. They have the disorder. So what must have happened here is recombination took place where instead of the B being on the small d, we have the B being on the big disease gene D. And then DC from mom. So we're going to write this person as being recombinant. Now let's go over here. AC. So DA from dad, like normal. DC from mom, non-recombinant. And then here, we can actually set these people up. So this person has a DA and then a DC, and then the mom here, she's homozygous. She's always going to give a small d and a C. So then this child got a small dc from dad and then a small dc from mom. So this person is non-recombinant. Now let's take a look at these people. So this person has a small db and a small dc. Then this person doesn't have the disorder either. So they have little d with a marker D, little d with the marker D. Now what we notice is that we don't have a capital D here for the gene. This capital D is not the gene, it's the marker. So essentially, the disease gene dropped out. And if this happens, these people can't be scored. So we're going to skip over them. So now let's take a look at this. This person, guess right over here, does not have the disease. So small d, a marker, small d, a marker. Then as we said before, this person has the disorder, so they have a capital D with a B and then small d with a C. So their kid who is a B got a small d-A from dad and a big D-B from mom. And this person is shaded in as they should be because they have the big D allele. So this kid is non-recombinant. Here we have a C. So we got a DA from dad and then DC from mom. This is non-recombinant because they aren't supposed to be shaded in. Here we have AB. This is the same thing as the one here, so it's non-recombinant. And here we have AC, which is the same thing as the one here, so it's non-recombinant. So now that we scored everyone, let's go ahead and count how much we have of the N's and how much we have of the R's. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Going to have 10 N's. And then we only have one R, which is right here. So then our total is 11. And we can write out this equation because this is phase known. Theta, our R is going to be 1. And we have 1 minus theta. Our N is 10. Divided by 0.5 of the total, which is 11. And now what you want to do is, as before, set up a table of values of theta and then plug them into here and here to see if you're going to get a LOD score greater than or equal to 3. So I created a table right here, and now we're able to plug in. So we take the log, and I'm going to plug in 0.05 for theta. That's to the first. 1 minus 0.05 to the 10th. 0.5 to the 11th. And we get 1.78, or just 1.8. And then now go through and plug in everything. And after plugging in all of the values, we see that our LOD score is not greater than or equal to 3. So our answer is going to be no, the disease gene is not linked to the marker.